who aren't logged in yet. All right, guys. Good morning. Thanks for being logged in. To those of you who are here, it's Thursday, December 17th. And I appreciate you guys being on time to class, being up this morning. We are going to review kind of a little bit what we did yesterday, and then we are going to continue to reinforce that today. We are talking about equations that have infinite solutions and equations that have no solution. So as you can see on the whiteboard, I have put up kind of a summary of a little bit of what we have been doing over the last day or so, or day or two this week, where we have some equations have infinite solutions and some equations have no solution. Most equations we do have one solution. If you solve for the variable, in many cases it's x, some cases it's b or c or whatever letter they pick, right? If you are able to solve that equation and get it down to x equals whatever, then that has one solution, right? That has one solution, and it's the only solution for that equation. But there are times when there are infinite solutions or no solutions as well. So we also have situations where we have the same number of x's on both sides of the equation, right? So if I have, let me do this. If I have an equation where I see, let's do this. Oops. Dang it. Go back. If I have an equation where I see the same number of x's on both sides of the equation, 4x and 4x, I'm going to know that I'm going to eliminate all these x's, right? Because what do we have to do to move these x's to combine them? We have to do the opposite, right? So this is a positive 4x, right? We assume it's positive because there's no sign. So we would have to subtract 4x. But if we subtract 4x over here, well, 4x minus 4x is 0, and 4x minus 4x is 0. So we eliminate all the x's. We have none left, right? So another way of saying this is if you see the same number of x's or the same number of variables on both sides of the equation, you are going to end up eliminating all of the x's, okay? So again, if there are the same number of x's on both sides after you've combined your like terms, you are either going to have infinite solutions or no solutions. In this case, you have infinite solutions, right? Because then you end up with 8 equals 8, or positive 8 equals positive 8. So that's a true statement, right? 8 equals 8. That's true. So this particular equation would be infinite solutions. All right, I'm going to erase a little bit of this. Now, let's say we go and change this up. Let's say I have 4x plus 8 and I have 4x minus 6. Well, again, same thing. We can look at these and we know that these are going to eliminate each other. These 4x's, we have the same number of x's on both sides. So we know these are going to eliminate each other. Because if I try to move them, I subtract 4x and that's done. I subtract 4x over here because whatever I do to one side, I have to do to the other side, right? I have to do the same thing to both sides of the equal sign. So if I subtract 4x from here and get rid of it, that gets rid of these too. I had the same number of x's, so I know those are going to be eliminated. But now we end up with 8 equals negative 6. That is a false statement, right? That is a false statement. So we cannot have any solutions because that is false, right? So whatever number I put in for x, whatever number I would plug in there, we could never have a solution for that problem. It's a false statement, right? If it has infinite solutions, that means I could plug in any number I pick for x and it would still work, right? If I put in, 7 or 22 or 916 or whatever, I could pick any number. In this case, any number I pick would never work because positive 8 can never equal negative 6. So there's literally no possible way to do that problem. There's no possible way to plug in a value of x that would make this equation work, right? Anybody got any questions over that before I go on? Or kind of erase this. You can kind of skip steps here. You can, if you want to eliminate these and show, as you're doing them on a piece of paper, and you really need to do these on a piece of paper, right? When you're doing your homework. I know some of you guys are having trouble with it. Make sure you grab a pencil or a pen and a piece of paper to actually work these problems out, because it's really hard to do them in your head, okay? It's really hard to do these problems in your head when you're solving equations. You need to work through it and show your work and do it step by step so that you can get to the end, okay? You are not just going to be able to click through these and answer the questions by doing them in your head. That's I don't even do that. I show my work and work it out, and do the opposite operations, right? If this is plus 4, I subtract 4 and then subtract 4. Or if I were trying to move, if I was trying to move plus 8, then I would have to do the opposite operation, minus 8, and do the same thing to both sides, right? Get rid of it. Negative 6 minus 8 equals, negative 14. You guys need to show work and do these on a piece of paper, because it is really difficult, maybe even, I would say, impractical to try to do these in your head. Like, you're not gonna get the right answer most of the time if you try to get these done in your head. Doesn't work, okay? So make sure when you guys are doing your homework that you are using a pencil and a piece of paper to actually do the work and practice the techniques that we're doing. Let me look up the page in the workbook too. We are on 2-4, example 4. So that would be that would be page 110. That would be page 110 in the workbook. So again, here's the page, here's the workbook. You guys all have this. If you turn to 110, you can follow along with these examples, okay? Page 110 in your workbook. All right, we're looking at some equations here, and it says, how can you determine the number of solutions in each equation without solving? So this is what I was just talking about, right? If we go back and look at this one more time, this is kind of what I was talking about here. If you end up with x equals something, you have one solution. So the only way you can end up with x equals something is you have an uneven number of x's on both sides. And I say x in general, right? Sometimes they use a or b or c or whatever, z or y, but I'm talking about a letter. If you have a different number of letters on both sides of the equation, you can solve for that letter, right? You will have the answer. If you have the same number of variables, you're never going to be able to solve that equation for one number. It's either going to be infinite or none. So how can you determine the number of solutions in each equation has without solving them? Well, I just gave you a trick. If you have a different number of x's on both sides, you can solve it. If you have the same number of x's on both sides, then all you need to look at is, do we have a true statement? So let's look at this first one. Real quick, I'm going to switch over to it so you guys can see it. X plus 3 plus 7 equals 2x minus 10 minus x. Let me copy that over to the whiteboard and we'll work through this. And I'm going to get some of you guys to give me some ideas here. X plus 3 plus 7. Let's clear all this. Let's write it a little bit higher so we have some more space. Equals 2x minus 10 minus x. All right, so we've got this equation here, and it wants us to solve to see how many solutions we have. So what are some terms that are like terms that you guys see that we need to combine here? Can anybody identify, like there's two sides of this equation. I'm going to draw a line right down the middle of the equation here. You know what? Heck with it. I'm just going to draw the line right there. There are two sides of the equation. So let's look at the left side first. There are two terms that are like terms there that need to be combined. Before we do anything else, we always need to combine our like terms. So what stuff over here needs to be combined? Can you combine x with 3? X plus 3. Can we add x's and 3's?
No.
No. Can we add x's and 7's?
No. We gotta add 3 plus 7 to 10.
Yes. Awesome. Yes, that is correct. We can add 3's and 7's, right? They're both numbers. So we have to combine them. It's a plus 3 and a plus 7. So like you said, that's correct. It ends up being x plus 10, right? Because 3 plus 7 is 10. We know that. So,
You know it's on the same page.
oh, sorry. Let me come over to the new page. Yeah, my bad. Okay, there it is. So, all right. So we combined the 3 and the 7 and we made 10, right? You guys have seen me do this kind of like, in this manner, right? I added the 3 and the 7 to make 10 because they're like terms. That makes sense. Now, what like terms do we have on the right side? What is in this stuff? What do we have? What can we add together? Can we add 2x and minus 10?
Yeah.
I don't think we can.
No.
We were just doing
We
that.
can we add 2x
Times 10.
Well, it's not a time problem. Again, the x.
no, 2x minus x.
Yeah, 2x minus x. There you go. That is not a time sign. That is a letter x. Those are two different things. So I know that can be confusing, but those are two different things, right? So this is we're solving for x. X is a variable. X is not a symbol, it's a variable here. So that's why I honestly like it when they use like A's or B's or whatever. They use a different.
It's gonna be 10. It's gonna be 10 equals negative 20.
We got 2x minus x. So if we have 2x,
but you gotta add the 2 to the 0.
Well, let's do this one first. If we have 2 x's and we take one away, then how many x's do we have left? 1, right? 2 x. I had 2 and I took 1 away. So I have 1 left. I just have x, 1x. Now, what do we have over here? We have the minus 10 just comes down, right? The minus 10 just comes down. So what do we end up with here? We were just talking about this. We have the same number of x's on both sides. So are we going to be able to solve this problem?
No.
No, we are not. Correct. Yeah, we have to have a different number of x's. We need to end up with like if we have 7x equals 10x, well, let's do a different example. 7x equals 3x plus 8. Well, in that case, we have a different number, so we can subtract 3x from both sides, right? And it gets rid of one side, but then we still have 4x's left on the other side, so we can continue solving, right? Then we just divide by 4, and 8 divided by 4 equals 2. So we could solve it. We have different number of x's on both sides, right? That's possible to solve. That's a one solution problem. But these, if we have the same number of x's, we are not going to be able to solve this. So let's look at these. We know we're going to be able to, we know eventually that these x's are going to disappear. Like if I subtract x and I subtract x, they disappear. So what do we end up with? We end up with plus 10 equals minus 10. Is that a true statement? Positive 10 equals negative 10. No, it's not. Yeah, good. It's not a true statement. So without even doing all this, as soon as I count up, like I don't even have to do this minus x and minus x. Like if I just go back to my regular problem here, and if I just look at these, this one you almost can do. What it's asking you is you almost can do these in your head. So here's what it's asking. It's asking us to figure out what this is. So I can't really highlight on here, can I? But can you guys see at least my mouse? Can you see my little cursor arrow on the screen?
Yeah.
Okay. So you look at this side of the equation, you have x plus 3 plus 7. So you combine 3 and 7 into 10, you have x plus 10, and over here you have 2x minus an x, so you have x minus 10, right? So you know right away, without even solving it, you have the same number of x's, so you're not going to be able to solve. And then if you just think about it, you have plus 3 and plus 7, that's positive, and you have a minus 10. So right now we have a non-true statement. We have a false statement, right? What it's asking us to do is pick. So this is what this represents, right? X plus 10 does not equal x minus 10. And you guys can see the little equal sign with the slash through it. That means does not equal, right? That means does not equal. So that means that the statement is not true. It's false. It's a false statement. So we know that this one right here is no solutions because it's a false statement, right? So let's do the other one here. This one's a little trickier, but it's not too tricky here, really, because this side is already the way it needs to be, 3x plus 12. There's nothing else we can do here, right? We can't add x's and 12s. We have to add numbers and numbers or x's and x's. So this side is done. Now this side, the one thing we have to do is distribute. So I will go to the whiteboard and show you how to distribute this. I don't want to just clear my whole frame because then I'll lose my notes at the top. So just bear with me while I click the button like 46 times to erase all my lines. Okay, so 3x, 3 times the quantity. When somebody says times the quantity of, they mean there's parentheses there. So that's the let me switch over here. So this is our problem. Obviously we have parentheses, so we are distributing, right? We are multiplying, because parentheses mean multiply. So we are multiplying the 3 times everything inside there. So the 3 gets times x, and the 3 gets times by 4, right? And what was the other side of our problem is already done. 3x plus 12. What do you guys think? Just by looking at this, can anybody already tell what's going to happen here? Are there going to be the same number of x's on both sides?
No. Yeah.
We've got a parentheses here, so we have to go 3 times x, right? 3 times x is 3x, and this has 3x, right? So we know we're going to have the same. Now, what's 3 times 4? Three times 4 is, and it's a positive 4 because we have a plus sign there. 3 times 4 is 12, and it's positive because there's a positive sign. And obviously 3 is positive because it doesn't have a sign. Doesn't have a sign, it's always positive, right? So look, what do we have? We have 3x plus 12 equals 3x plus 12. We know that the 3x's are going to cancel. If we were to start solving this, the 3x's would get rid of each other because we have the same amount of x's on both sides. So can we solve this?
Yes.
If we have the same number of x's on both sides, we cannot solve this. Remember? Like right above us in our notes here, if you eliminate all of the x's, right? If I were to try to start solving this, I would have to go, okay, let's subtract 3x to get rid of that. Well, we have to do the same thing to both sides. So, oh no, 3x minus 3x is 0. So I eliminated all the x's, right? And all I get is 12 equals 12. So what do we have? If we have a true statement, what do we have? It's right up here in notes. If we have a true statement, you have infinite solutions, right? You could put anything, any number, you could pick whatever number you want to put into x, and this would still always be true. That's what that means. So let's go back here and see which one we need to put in here. Okay, this is what we got, right? This guy right here. 3x plus 12 equals 3x plus 12. So again, this one you could, if you're really good at distributing, you could just look at that and go, okay, the 3 is getting multiplied by everything inside these parentheses, right? The 3 is getting multiplied by everything in here. So I know that it's going to be 3x, right? Because it's 3 times x. And I know it's going to be 12 because it's 3 times 4. Times 4 is 12. So I know I'm going to get 3x plus 12 on both sides of my equation. So I know if I have the same thing, if I have a true statement, then I have infinite solutions, right? If I have a true statement, I have infinite solutions. Now let's look at this last one. This last one is one that we can solve. We know what it's going to be, I guess, on the choices, but let's solve it. 5x plus 8 equals 2x minus 1. Five x plus 8 equals, sorry, don't want to erase my notes. That's all right, we'll do it in red. What a terrible x. What a terrible, pathetic x. 2x minus 1. All right, so this one, what do you notice right away? Do we have the same number of x's on both sides?
No.
No. One has 5 and one has 2. That's a good thing because now it is possible to solve this for one solution, right? It's possible to solve this for x because we have a different number of x's. So the first thing I'm going to do is I'm going to move things around so that I can combine like terms and solve for the equation. So I'm going to pick the smaller number and I am going to subtract it. Minus 2x, right? Well, 2x minus 2x is 0, so that's done. Now we have to do that same thing to the right side or the left side. We do minus 2x here because we did minus 2x here, right? Whatever you do to one side, you have to do to the other side. 5x minus 2x is what? You had 5 xylophones and you took 2 of them away.
1.
5x minus 2x is 1?
No.
What's 5 minus 2?
3.
Yes, correct, right? 5x minus 2x is 3x. Now, we can't have this plus 8 be with our x's, right? So we had to do the opposite of that, which is minus 8. Like 8 minus 8 is 0, right? So I have to do a minus 8 over here. Negative 1 minus 8. So I'm already in negatives by one number, right? I'm one number left of 0 on the number line, and I'm going to go 8 more spaces to the left. So what do I end up with? Negative 1 minus 8.
Negative 1 minus 8.
It's negative plus another negative, so we know our answer is going to be negative, right? If you're
I
if you
think it's -3. I think.
if you start in negative and you go more negative, you're going to continue to be negative. It's not possible to add two negative numbers and get a positive, right? We know that.
-9. I
So,
think.
-9, you got it. Yep, good. So now we have one more step. We have to isolate the variable, right? We need x to be alone. Right now we have a 3x, so that means 3 times x, right? Anytime we have two things next to each other with no signs, we know that that's times. So the opposite of times would be what? I said this the other day. The last step in these problems, times is multiply. Times is multiply. What's the opposite of that?
Divide.
Divide. Yep. And like I said the other day, the last step in these problems is 90 to 95% of the time it's going to be divide. Every once in a while you end up with a fraction, so you have to multiply by the reciprocal. But typically the last step is going to be divide, right? So if I divide 3 divided by 3, the 3's are going to cancel. That's good, right? That's what we want. We want x to be alone. So yeah, then we have to go -9 divided by 3. Well, what's 9 divided by 3?
That's 3.
3, correct. And we have a negative sign, so we have to put in
-3.
sign. So yeah, there you go, right? So this one, we ended up with a different, we started out with a different number of x's.
But we end up with a different number.
So we know if we start with a different number of x's on both sides, we know that we are going to be able to solve this. Not we're allowed to solve this. We know we will be able to solve this problem because we have 5x on one side and 2x on the other. If you have the same number of x's, that is when you're going to run into these two scenarios where they eliminate each other and you either have a true statement or a false statement. If you have different number of x's, you're going to have this scenario. You're going to end up with x equals something. That's what we did. X equals -3. X equals -3 is our solution. That's the one solution. That's the answer to the problem, right? So we got to go back to the example here after I erase all this. Sorry, bear with me. There we go. Okay. So we obviously know that this is the answer, but hey, they got the same answer we did, so that's good. 3x equals -9, and then the last step would be divide both sides by 3x to solve the problem. But you can almost match these up and figure out whether there's a solution or not just by looking at them. Oh, sorry, trying to wake up. Like the first one was the easiest one, I think, because you just have one x and then you have +10, 3 + 7. You have 2x minus an x, so you have 1x over here. Same number of x's, but you have a +10 equals a -10. Well, +10 does not equal -10. So you know that this is no solution. We already proved that this has infinite solutions, right? Because 3x + 12 equals 3x + 12. That's a true statement. The 3x's would eliminate each other. We just have 12 + 12. And then we just did C. So C has a solution of -3. So let's do a couple more of these. And so this is just them explaining it. So I won't go into this too much because obviously this is what we just talked about. But this one's talking about you can combine the terms mentally. Like you can almost do this one in your head, right? You got 3 + 7 is 10, and you got -10 over here. So you know that these do not equal each other, right? That's unequal. It's a false statement. It's not true. So you know that it has no solutions. I won't go through all of this because we already talked about it, but obviously the second one is infinite solutions, right? Because you have a +12 and a +12. So that is a true statement, right? These are the same, so you have a true statement. And then this one, right? You have a different number of x's, so you have one solution. Okay. It's going to ask us to do a couple more here. I'm going to leave this up for 1 second. Give me 1 second as I got to step away from the computer for literally 10 seconds. All right, I'm back. Sorry about that. This is going to ask us to use reasoning to figure out the number of solutions. It's not even asking us to solve them. We might do it for fun, just, to practice, but it wants us to use reasoning to figure out if there are no solutions, infinite solutions, or one solution. So I'm going to pick a color here. And that's about right. Make it a little smaller. Let's make it that. All right, cool. So we need to figure out whether there are no solutions, infinite solutions, or one solution. Let's look at A. And they put this down. I don't know why this stuff goes over here. So I'm just going to rewrite it.
Mr. Levine,
Yes.
what time is this class over? Because I have to go to my auntie house for school.
This is over at 9:15.
Okay.
But if you need to leave, we will probably be done early, and then I'm going to give you guys like 15 or 20 minutes to work on homework and or help, because I know Orlando was asking me this morning. He was struggling on a couple assignments, and he asked me to help him out. So I'm going to do that for the last 15, 20 minutes. So if you do need to leave, like, if you want to leave like 10 minutes early, that's okay. But I'll let you know when we're done. Okay.
Okay.
So let's look at, let's use red for this. Let's use red. Let's look at this first one, letter A. Like, again, the key to this, to knowing whether or not we're going to be able to solve the equation, is to look at the x's. If there are the same number of x's on both sides, then we know we are not going to be able to solve it. But in this case, are there the same amount of x's?
No.
No, one has 3x and one has 2.5x. So we know that this one will have one solution. We can solve for this problem, x equals something. We don't know what it is until we solve it, but we could solve that problem, right?
Yeah.
Let's look at the second one. Well, in this one, you have to distribute, right? So we have 3x. I'm going to rewrite it right here. 3 times x is 3x. 3 times positive 2 is positive 6. So let's look at what we got. Do we have the same number of x's?
Yeah.
Yes. Do we have a true statement or a false statement?
A false statement.
We have
No,
a false
true.
statement. Yep.
False.
So yeah, you're right. You just said it. Are there what solutions are there, Orlando?
False statements.
So a false statement, do you have infinite solutions or no solutions?
No solutions.
Yes. Good job. You have no solutions because that is a false statement. We have the same number of x's, but 6 does not equal -6. That's a false statement. So,
False statement.
yep, false statement, no solutions. So that kind of gives away what the third one is, but let's look at it just to be, just for the sake of, we have to combine these two things, right? We have like terms here.
Yeah.
5x plus 4x. Well, that's 9x, right? 9x
Yeah.
minus 4. So if we look at these, we have a 9x and we have a 9x. So we have the same number of x's, right? So
Yeah.
now we look at
-4.
-4 equals -4. That's a true statement.
Yeah,
Correct.
because it got 3. No, not my.
-4 equals -4. They're the same thing. That's a
Yeah.
true statement. So we have infinite
Infinite
solutions,
solution,
right? And if we wanted to go through and solve these, we could,
but it's
but
hard.
it was just asking us you can determine a lot of times, like
Ooh,
if you
yeah.
see these on tests or whatever, like you can determine whether or not you're going to be able to solve it, right away. And then obviously this one right here,
Mm,
we could try to solve if we wanted to, right? If I
Yeah.
erase this, like let's try to solve this and figure out what it is. Because
Which
this
one?
letter A. Letter A is the only one we can solve. We already know that B has no solutions and C has infinite solutions, right? We know we
Yeah.
can't solve those. So A is the only one we actually could solve if we wanted to.
So 3 times. Let me got the calculator right there.
Well, the calculator's not going to help us until a little later. But so we got 2.5x here and we got to get rid of it. So I subtracted 2.5x from both sides. 3x minus 2.5. That one a calculator might help, right? But 3 minus 2.5 is
3
0.5.
minus 2.5 equals 0.5.
Yep. So I got 0.5x. And then I have a plus 1.5 here. So in order to get rid of that, I'm going to have to go minus 1. Dang it. Sorry, I'm trying to write really small and my stylus is not cooperating. Right? But I have 1.5, so I subtract 1.5 to get rid of it.
And that equals 0.4. No.
4.7 minus 1.5.
Hold up. 4.7 minus what?
Minus 1.5.
3.2.
Yep.
3.2. Whoa.
So then our last step is going to be division. So do this one as well. In order to get rid of this 0.5, we have to divide by it, right?
divide
So,
by 0.
Yep, 3.2 divided by 0.5.
4.7, I think.
It should be, I think it should be 6.4. Punch it in again. 3.2 divided by 0.5.
3.2 divided by what?
0.5.
Mr. V.
6.4.
Mr. V, I have
Yep.
to leave now.
Okay, that's fine.
All right,
That's fine.
bye-bye.
All right, thanks for being here.
You too.
Woo. Woo. God.
So,
Online is hard to do. In person, it's easy.
I'm with you, man. I'm with you. I agree. I wish we could be in the class right now.
Because in person, you could just talk about it, write it down. Now that you can write it down without the sound out your mouth.
I know. It's like it sucks for everybody, man. I don't like doing this either. To be quite honest with you, I don't like doing this either. But that's kind of that's the circumstances we're dealing with right now. So not my decision to make. But
See, look, when I get order, I'm start doing YouTube. I'm gonna start doing YouTube.
just like I'm doing right now. I save all these on you. I save all these. I know you guys know this, but I save all these
On
classes
YouTube.
and I put them on YouTube. So if you guys ever want to go back and look at something that you are confused about, or if
Remove a
you
few.
like didn't wake up on time and you
I'm sorry, I can't do that. Orlando,
you're
stop talking to me like you crazy.
yeah, if you are confused on something or you need to go back and look at something because you maybe didn't wake up in time or whatever on the day, you can go back and watch all of the videos from class ever since we went back to remote online. You know, we were obviously I wasn't recording while we were in class because everybody was there in class, but now that we're back online, I put all these videos on YouTube so that you guys can look them up. So the link is on the Schoology page for this class. You can click the link and it'll go right to the playlist of Math 8.
I'm bored.
All right, let's go do this last
Man,
do this last one, and that'll finish out our lesson, and that'll be a great stopping point actually for our quarter because obviously you guys know that the quarter is over tomorrow when Christmas break starts.
it ends tomorrow morning. I'm for real. No, I mean tomorrow night. It starts tomorrow night.
I thought you were trying to play a joke because you didn't want to come to school tomorrow. The quarter's over. I don't need to come to school. But yeah, it's over. That's what I thought you were trying to say to me. Oh, it's over tomorrow morning, so I don't have to come to school tomorrow. No, it's over tomorrow night. So yeah, you still need to go to your classes. Yeah, you still got to go to classes tomorrow. But then we are done after tomorrow. We get a nice little 2-week break.
Man, I'm not gonna go to school. I'm not gonna go to class tomorrow, man.
You need to go because you need to make sure you're caught up in all your work. So that you
look. All the guy needs to do is your class and John class. You're not doing like.
Okay.
That's easy.
Okay. Well, just make sure you guys are catching up, or make sure you guys are caught up. And I obviously can help you guys catch up on stuff later on. I'm gonna do this last problem here, and then we will. Then I can help you guys work on some homework.
All right, I'll for the big person my screen, so you can see. So you got them glitch back down.
Right. Let's do this one. All right. I'm gonna.
What happened?
Nothing happened. I'm just going over to mute you because you're talking and making jokes and stuff. And I'm gonna start one more problem. All right. All right. Thanks. What happened? Oh, resume. There you go. All right. So you're seeing this. Let's try this one. The other one was with fractions. So let's do this one. I like this one better. Gilberto makes 7 bracelets and Sonia makes 5 bracelets. They both use the same color or the same number of string colors. How many colors should they use to make the same amount of money? So it gives us. Hold on. It gives us some info here. Gilberto makes $5 per bracelet plus $7 per string color. Okay, so he has a flat fee of $5 and then $7. Hold on. Let me get through all the info first. All right, so I'm gonna copy this over to the Jamboard. Gilberto his bracelet has a $5 flat fee, right? $5 per bracelet plus $7 per string color. Sonia has a $3 fee per bracelet and a $5 per string color. So let's put this in the Jamboard. 5, 7, and 3, 5. I'll do Gilberto in blue. Gilberto de Piento.
And do nothing. It's still on the question.
I know. I'm just switching it over. Thanks for reminding me. Gilberto de Piento. He has a $5 flat fee. Plus
5 plus 7. 5 plus 7. No, you're plus 7.
Well, you're
And-
right.
And then 5 plus 5.
5 plus 7 times what? Let me see what it's asking us. Let me make sure what it's asking us again.
5 plus 7 times 0.
So no, it's a C. Colors, right? $7 per color, right? So if you get 2 colors, it's $7 times 2, right? Because it's $7 per color. So if you get 3 colors, it's $7 times 3 colors, which is $21 plus the $5 fee, which would be 26, right? That's Gilberto. Gilberto de Piento.
I think.
Let's do Sonia. I'll do Sonia in red.
5 plus 5.
I thought it was 3. Isn't it 3?
No.
Let me check.
5
Three.
plus 5.
$3 per bracelet.
It was?
Yeah, it was $3 plus. You're right on the second one though. The second one is $5 times C. Right? Sonia charges $3 plus $5 per color. So let's see if we can solve for this equation. How many
we can.
colors should they use to make the same amount of money?
Let me add that up. 5 plus 7 equals 12. And then
Well,
3.
hold on. We can't do that.
So divide.
Because we have, those are not like terms. One has a letter attached to it and one doesn't. Those are not like terms. So what I need to do is I got to start combining these things, right?
Oh my God, I hate this combined stuff.
I'm going to move I'm going to move this by subtracting 5C, right?
Yeah, there.
5C minus 5C is 0.
Yeah,
7 minus 5 is 2C. Now, I need to deal with this. I got to get this over to the other side. So I have $5, so I'm going to subtract 5, right?
Oh, my bad. I'm in myself.
Thank you. So 5 minus 5 is 0. 3 minus 5 is -2. Now, if we were to solve, our last step would be divide by 2, right? Because that would cancel out those 2's. And then -2 divided by 2 is -1. But let's think about what it asks us. We solved the equation and we got -1. But let's go back and see what it's asking us. It is asking us, how many colors should they use to make the same amount of money? Our answer was -1. Is it possible for them to use -1 colors on making their bracelets?
No.
No, it's not possible. So this, even though we were able to solve the equation,
it was only gonna be enough for like one person.
well, no,
I think
it's not even enough for one person. It's not possible to use -1 colors.
Oops,
right?
My bad.
So this is no solution. Well, technically there is a solution, but the solution is -1. So it's an impossible situation. They can't use -1 colors. How can you possibly make a bracelet out of -1 colors? That means
cut
there's
it up.
no colors minus.
Cut it up even.
It doesn't make sense, right? So
No.
there's no possible way to do it. So
It won't be enough.
let's see what they said on the next page.
Next page. It said right and a question.
That looked like too much.
They did it a different way.
Killer, be quiet, bro. You don't know what you're talking about.
Who you talking to?
I'm talking to you. Bunny Rabbit.
Oh, we forgot one thing.
Oh my God.
But you know what? It doesn't really matter. We ended up with the same. I totally forgot that Gilberto makes 7 and Sonia makes 5.
Right, I said
Forgot that part. But they still come up with the same thing, right?
Yeah,
Here's what here's where we went wrong. I set it up like this, 7x, like right. That's how I set it up. 7x plus 5. I use the letter C instead of the letter X, and 5x plus 3. But Gil made 5 and Sonia made 7. So we had to distribute. 5 times 7 is 35, right? 5 times 5 is 25. And then 5 times 7 is 35, and 7 times 3 is 21. So then they look, you end up with the same amount of you end up with the same amount of x's on both sides.
Yep.
So you know there's going to be either infinite or no solutions. But you have a 25 on one side and a 21 on the other side. So, oops. You know that 25 does not equal 21. So this is not possible. It's never going to be possible for them to make the same amount of money because 25 does not equal 21.
Right.
Right. All right.
Right.
So sorry about the confusion on that. I kind of screwed that one up moderately, but
Yep.
I make mistakes too. I'm not perfect.
Sometimes.
No, I'm not perfect. I'm never not perfect all the time.
At school.
Let's do this. I am going to save this.
My schoolwork are bad.